Do you know about Aristotle's wheel paradox? The paradox first appeared in the Greek work Mechanica, attributed to Aristotle. If you have a wheel of radius r, and want to know its circumference, you can just roll the wheel for one full revolution, and measure the distance traveled. Now, let's glue another wheel with smaller radius to the larger wheel, such that their centers coincide. Now if you roll them for one full revolution, the distances moved by both wheels' circumferences are the same. The distance traveled by the larger wheel is equal to its circumference, but for the smaller wheel, it is greater than its circumference, thereby creating a paradox. To understand the paradox, let's fix a point A on the circumference of the larger wheel. Now, if you trace the path of the point when the wheel completes one full revolution, without slipping, the path is called its cycloid path. Next, if you take a point B on the circumference of the smaller wheel, and trace its cycloid path, you can notice some important observations. The centers of both the circles traveled a distance 2 pi r, but the cycloid path of point B is shorter than that of point A. Also, point A performed a perfect rolling without slipping motion, but the point B slipped during this interval. So, the smaller wheel is dragged along by the larger wheel, creating the paradox. An alternate version of the paradox is when the smaller wheel is in contact with the horizontal surface like a train wheel. In this case the larger wheel is dragged along by the smaller wheel. Isn't that interesting?